So this is the past, present, and future of extensions management. I just did a little blog post on krypted.com, krypted.com, that includes this presentation and part one, which I delivered at macad.uk. I kind of hoped it would be up before I got here today, but it's not. So when it gets up, I'll post it, but you don't need to write down any of the links or any of the code or any of the other stuff because it's all in the keynotes. Everything I show, I literally uploaded it after I changed my last slide, although I can't promise I didn't change anything else because that's what you do. So again, it's part two. Part one was a couple months ago. There are some net new tools that I built for this that are up on GitHub, and there's a couple that are half done, and I'll get into why those are half done and where they're at and how you can get access to them if you so choose. So I started getting into extensions. I started writing, you might call it a password manager, but it's more of a quantum safe encryption kit. I called it Secret Chest because I name all of my software when it's in beta after Dungeons & Dragons spells. So any of you who know Liam on Secret Chest, you put the things in, it goes to the astral plane. The analogy really starts to break down because I'm not good at those. But in the process, I started to realize how much we build on the shoulders of giants. And I have to say, it's wonderful not to write code in zeros and ones. It's wonderful not to write code in hex. It's wonderful to just be able to import things and, for example, get another dialog box that offers a second set of credential locations. So this is using the autofill system extension, or app extension, which should probably be a system extension, but we'll get into why that is later. And so I was able to get this little piece done in about 10 minutes. And Apple makes it as easy as in Xcode. I click on File, I click on New Target, and they have all these templates. And there are all these little open source libraries out there, and you can start writing code from scratch, but it's a horrible, horrible, horrible idea that is doomed to failure in most cases. It's easier to start from a template and add your code on top. So in my example, there's encryption libraries that I'm pulling things out of, but being able to get all of the stuff that you see with Keychain for free is allowed me to get a lot more done in a lot less time than I would like, which gave me more time to do other crazy things. Apple also has lots of great documentation for building extensions. Every extension has a slew of documentation. Some are what we call kits, where you have documentation and all kinds of other stuff, kind of sample code wrapped in. And some are just, this is an extension, good luck with that, like the new passcode extensions. If anyone's tried to tinker with that, where they forget to include information like, oh, what you need is in the header of an assertion, and you have to just kind of figure that out by spelunking. So a lot of this presentation is me spelunking and grabbing screenshots while I went, which is why there's so many. Once you build an app and compile it, then it's fairly simple to provide entitlements to the app and go to town. And we've all seen these and checked those boxes for other things. So one thing that I'm not a good software developer. I'm really, really bad at it. So when I built my first autofill extension, I caused iCloud Keychain to never work again on that machine. And back in the 90s, and I see plenty of people with gray hair like me, so you'll remember we called those extension conflicts. So extensions could conflict in OS 6, or even earlier, through 9.2.2, and we're back in a state where OS extensions can conflict again. Back then, though, we had this wonderful tool. Who in the room remembers this? How many machines do you think it took me to get this screenshot? And this is how we did screenshots, remember? Click. But back then, we had this wonderful tool called Extensions Manager. We could turn them off, turn them on, create sets of them back when we had sets for all the things. And life was good. You know, you could also do like split half troubleshooting where you boot the machine into safe mode, rip them out of the extensions folder, throw them on the desktop, and you're good to go. Who has euphoric recall about that era? We are sorely mistaken. There was nothing good about that era. So what I did in my DevOps, so I was building this app, and I decided to, you know, make a tool for me to be able to see if my extension was loading, or maybe even if my extension crashed other machines or other daemons that relied on the same code as my extension. So there was nothing around to do this kind of stuff, so I ended up writing a new tool that I called Extensions Manager. Very creative I am, in case you hadn't noticed. I named software after Dungeons & Dragons spells or steal probably trademarked software names from Apple. So that's available for download. Feel free to take it. I would say what I was trying to get for this session that I didn't quite get to was I wanted to get this on the App Store. And extensions can't talk to other extensions unless they're entitled to do so, and so it's really complicated to get telemetry into extensions in a form that it can be put on the App Store. So I'm about 90% there. Hopefully it'll be available by Mac sysadmin, which will be in October. So I showed a screen of how we add extensions, and then I mentioned that we don't have a lot of telemetry into what these things are doing. And in my mind, just to throw this out there, extensions are the most dangerous thing on our computers today, potentially. I'll go through some of the options, but you can get extremely detailed information about what systems are doing with them. So I added, and I would also add that as we deploy these things, the instrumentation tools in Xcode give us a bunch of options for how to troubleshoot our code. But once it's in the wild, the full atomic operation of, oh, go retrieve that password, which requires a second device for an MFA and all these other things, when it breaks down, instrumentation options in Xcode give us very little information about what's actually happening. So we wrote this framework for Secret Chest, which will open source separately, maybe by Mac sysadmin, that gives us the ability to then basically take a functional programming approach to showing how our information is flowing between our different functions and classes. So this is an example of just some random task that I'm trying to perform within Secret Chest. I created a developer view, it fails. I have a very quick ability to triangulate what went wrong and where. And this has taken it from it taking 3-4 days to fix an escape defect down to it taking sometimes 5 minutes. Because you see, oh, this function is where it failed. As a red X if it failed. I should have grabbed one of those for this. And then I can go fix the code where I invariably screwed it up because, again, I'm not a very good programmer. Now, I can also take that information and pipeline it to my web server, optionally. Of course, you would allow people to disable this if they're like, I don't want people creeping on when I use passwords. But this then gives me the ability to add a webhook to each endpoint, and you can pipe it all out to your SIM, for those of you using a SIM. So to me, this not only helped us fix our own problems faster, but it also helped give potential clients, and we're in beta, we haven't released, but it gives them the ability to get that same level of telemetry that I have. And also non-repudiation, they can see what level of telemetry I have. Like, I never want to see a password in any of these logs, as an example. So the way I ended the previous session, which was on the past of extensions management, was kernel extensions are deprecated, the end, go home, I'll see you later. It wouldn't be true to say that kernel extensions are gone. They're still there, they still can work, and they communicate through this layer called XPC, which I went into in a little more detail in the previous session. Today, we've actually added a new layer on top of XPC that that's kind of an intermediary that adds a whole bunch of other options. So extensions can work. There's the link for how to make them work. And there are some tools that still require you to load them. Sometimes you even have to disable SIP. So as an example, SoftRaid, if anyone's used that to run like a RAID 60 or RAID 51 on their local machines, they require that, and this is where that stuff lives. It's all the old stuff. SPCTL still works for all that old stuff. KMUTIL still works for all that old stuff, but we're on to new and better things. We can also still use MDM to approve texts. I don't know how long this will last, but this is a screenshot of where to do that in Jamf Pro. I try to be vendor agnostic, so anytime I use a screenshot from one vendor, screenshots later in the presentation will be from other vendors. If there are any vendors in the room, don't be offended that I'm using your competitors' screenshots in my decks, please. So XPC modernized means we add entitlements, we add sandboxes, and we add notarizations. Those are the three cornerstones of protecting people's privacy and giving people telemetry into what software is doing on their machines. And what we replace kernel extensions with are purpose-built extensions, app extensions, network extensions, system extensions. And I added this later in the presentation because I decided it was equally as dangerous, if not more than anything else on the machine, browser extensions. And has anyone built a browser extension by any chance? They're JavaScripts, and you can see them in the clear, you can see what they do, and most browsers also don't require them to be unchanged, so you can often inject arbitrary code into these JavaScripts. It's kind of like using dylibs back in the day. So the first of these to appear was app extensions for iOS 8 and Mac OS 10.10 in 2014. And honestly, I didn't think that much of it because they hadn't announced that like kernel extensions were going to get deprecated. So it seemed like a nice, quick, cute way to add functionality to the operating system for my specific domain of expertise, whatever that happened to be at that time. So as an example, there are mail extensions. These are app extensions for mail. And if you see up in the little title bar of this email, there's a little logo when I load this extension, and it allows me to autofill text, which is not a native functionality to the mail app. Very nice to have, lots of productivity enhancements. A lot of times these are things that Apple doesn't see a wide enough market for, or they haven't gotten around to Sherlocking if they do see that wider, that wider need. And for anyone in the room who doesn't know the term Sherlocking, there used to be a tool called Sherlock. Apple added the functionality, and ever since we've called it Sherlocking because that company basically went out of business. So there are other extensions for, there are extensions for all kinds of things. The Quick Look is one. This is on the, I'm not sure which side you guys are seeing, sorry. On the left side, that's just the file listing inside the application bundle for suspicious package. And on the right side, it's the info plist for suspicious package. So in the previous one, I'll jump back. If you notice, the AppX is in the plugins folder. And that's a very logical place to put it. You're basically creating pluggable components for software. And in this case, if you notice, there's no plugins folder. There's no contents folder, which is where system extensions would be buried under. Instead, if we zoom in the info plist, we see he's just calling com.apple.quicklook.preview. So we don't have a streamlined, conformed experience for how these different various types of extensions work. In this case, it's just an info plist calling something that Apple then loads dynamically in my code or his code. And in the previous one, we're actually creating an artifact, a .appx bundle inside our .app bundle that is then loaded on demand. And the functionality that suspicious package can then give us with this system extension that they're calling is when we hit an extension, highlight an extension, hit the space bar, now they can show us a bunch of information, metadata about that package that they're parsing mostly from the info plist. So as a developer, he can do something that he probably couldn't do otherwise, and he can do so in a very short amount of time because Apple gave him these libraries of code to piggyback on the shoulders of giants. So one way to see extensions, as we just showed, is look at the app bundle. Sometimes extensions, just to be confusing, can load things into library application support. Sometimes they will be in applications or applications utilities and then nested in there. And then the other way is if they're just calling an extension and not dropping a net new extension, then it would just be parsing the info.plist bundle, or the info.plist. And there are 36 types of extensions. They all work a little bit differently. I've seen very little conformity across them as I've analyzed all this. Also, some overlap. So this is a little tool up on my GitHub I called Content Block Block. And all it does is uses Apple's Safari.content blocker extension to block any web page that has a given string in it. So I was thinking about maybe someday I'll build a content blocker. Content blocker sounds like the right extension for me, but the plist that the bad terms goes in can only be a certain size, and so I decided that wasn't the right choice for that project that I was working on, but I put the code out there anyways just because. For that, I ended up creating a network extension, and that is filtering at a whole different level. So this is an example URI block, and to show what it does, you enter some text. There are two buttons, allow, deny. And so if I say crypto.com, deny, no URL traffic for crypto.com goes through. If I say FTP:// then it would block all FTP traffic. So it just takes a string and concatenates it and refuses anything going through it. So this took 2 or 3 hours because, again, Apple gave me this wonderful kit of network extensions, and I was able to just import their template and go to town. So network extensions were introduced in 2017 for iOS 11 and macOS 10.15, and they grew to include not only the content filters, but also custom socket-based protocols, DNS proxies, transparent proxies, virtual machines, VPNs. Why virtual machines? I don't know. But if you were to add WireGuard as a back-end service, pipe all your stuff through there, then you have a pretty ZTNA. And that's just a buzzword for a lot of different things in my mind. All the ZTNA tools, by the way, pretty much use WireGuard. So open source, building on the shoulders of giants yet again. So when you're spelunking, so I had this goal. I wanted to build a tool, and I wanted to call it Extensions Manager just so I could get a cease and desist letter from Apple in the mail. Never happened. That's not framed behind my desk yet, regrettably. I'm counting the days. But as you're trying to surface this information, like, show me all the extensions on my machine. You start digging around and finding all these weird places where these things live. And there are some obvious places, like library preferences. There's com.apple.network extension. But by and large, the obvious places tend to be red herrings. So for example, in com.apple.network extension.control.plist, there is a key or an array for critical domains. And in there's cheeserolling.apple.com. There's also woollyjumper.apple.com. Nothing, these don't exist on the public internet. They're internal testing, I assume, QA URIs. But, I'm curious, whose dev machine is Locksmith? Whose dev machine is GDMF? And does GDMF mean what I think it means, which has expletives in it? And who moved into the office and then just named their machine Livability? Because why go home? In short, not much info in a lot of the common places that you might think to look for telemetry into what extensions are running on a machine, or in what ways your entire operating system might have been modified by an app, which, some of the fake coupon apps and where they're based out of, it's really interesting to think what people might be trying to do, especially with network extension. Anyways, in short, not much info in these places. Moving on to the next type of extensions, system extensions, introduced in 2019. And this was when the writing on the wall was there that kernel extensions were going away. Notice it's there for the Mac 10.15, not for iOS, because iOS doesn't need those kind of things, I guess. System extensions is really a framework. Frameworks are opinionated, I would say, libraries of code that we can bring into our code or build on top of. And by opinionated, I mean there are rules around how we consume APIs that Apple makes available. Sometimes very stringent rules. And in some cases, that's because some of the stuff that we're talking to is very dangerous. So in the system extensions world, applications send an activation request. We'll get into what's in the activation request in a hot minute. Or a deactivation request upon delete to the sysexd through the system extensions.framework. That then sends messages to kextd, endpoint security D, or any session manager, which should probably be called network extension D, but isn't, because it's too old to be named in the proper naming convention, and changing names and things is called technical debt, and none of us like technical debt. So kextd is for drivers and IOKit. I do not go any further into drivers and IOKit in this session because I have no code level experience with them and would feel like a complete fraud and charlatan telling you all about things that I don't know about. But user libexec endpoint security D is for the endpoint security extension for anyone using like a Jamf Protect or any of the other tools. Kanji has one that are piggybacking on this. This new extension, newish. I still think of new, and maybe that's the sign that you're getting old when you think of like things that aren't new anymore as new. But also, I need glasses. Just throwing that out there. Yeah, I can still see what's on the screen. Luckily, it's in really big text. So. Network extension framework, if you see a common theme here, it's that there are frameworks or bundles of things that we can then import into our things. And if you notice, system library extensions endpoint security.kext. So here Apple's created a text and they created an opinionated way for us to consume their text. And we'll have some screenshots of some of this later. And the network extension framework, same, very opinionated, and uses any session manager. So where's the so we install an app, let's say Little Snitch, one of the best network extensions made. Who loves Little Snitch? I hear a whoop. I'll give a whoop whoop in response to your whoop, because that seems appropriate. So where's the information? Library system extensions db.plist. So when an activation request is sent, this property list gets updated on the fly upon approval. And just to zoom in on something real quick, here we see the category or the type of extension that this is. It's a basic network extension. But we also see, and I forgot to highlight this in red, we see the team ID and a unique ID. The unique ID is important because it dynamically loads or copies the faux root of that location into library system extensions / unique identifier. And then in there, we'll see the info plist as it was in the Xcode project when it was built. All of this is terribly cumbersome to parse through. So Apple, in their wisdom, gave us the system extension CTL command, which then allows us to surface some of this information faster and easier, although I would say in an incomplete fashion. So, which, we learn as we go and we build more functionality into things as we go, also called technical debt probably. So Here we're querying the sys extension daemon, or the system extension daemon, and we're able to respond with certain pieces of information. So in the little snitch example, I'm just going to go through these real quick. This is what the entire installation looks like to get Little Snitch running. It's a lot of screenshots because there's a lot of buttons you have to hit, because Little Snitch actually blocks content. They don't just show you when new network connections are being made, they give you the option to block them, which is a separate extension. So if you've had to enter two different extension or two different bundle IDs or team IDs, this would be a potential reason why in your MDM to allow a network extension to fire up. It's because if we're doing two different things that use two different extensions, you might have to whitelist two different locations. So yeah, once it's done, if you notice, it says activation enabled under system extension CTL. So the information, to reiterate, in library system extensions / unique ID is copied there from the relative path in the app bundle itself upon activation. So allowing an enabling an extension isn't the same thing as allowing the extension to access your private data. So entitlements also come into play. And that's where we go into system preferences and we check that little box to allow things. This is a screen from Sandcorn. Tools that we've used so far in this presentation, by the way, Suspicious Package, Sandcorn. These are great tools for all of our arsenals, in my humble or not so humble opinion. Here we see that we've given access to the content filter provider once we've enabled that. And again, there's two extensions, and these are bundles as well in here, and they get imported into the code when it's run, or they can live resident. So another way to see some of this information is code sign. All of these things are cryptographically signed. So here we're using -D and -- entitlements, and we're able to see the developer ID, and a bunch of other metadata. Pretty much the same thing that gets displayed, except for this is checking the cryptographic signatures for it. Now, to remove these extensions, we just delete the app, right? Except we then get prompted for an admin credential potentially, and if you notice, it says at the end of this command, terminated, waiting to uninstall on reboot. So we've unloaded the extension, but we haven't removed it yet. That happens upon reboot after the app's deleted. So we have this modernized control mechanism, and we also want a modernized centralized control mechanism. So this is where the ability for MDMs to whitelist, allow list, or block list things comes into play. So we can use MDM to block extensions or allow extensions or block all extensions except for those allowed or what have you. And this is a screen from Kanji showing how easy that is. Just enter a team ID and whether or not you want to allow the system extension. You might have to enter more than one if an app loads multiple extensions. In my experience, with one exception, every single app that loads multiple extensions will have multiple entries in the app bundle, and so that's how you can figure out if there are multiple. Like if you were to load something and then it were failing, that's how I would go about looking to see. So here's another code sign. Again, that team ID, this one's parsed a little bit better, is right there and easy to use, as is the hash, so we can check anything we're deploying, like if we have an auto package workflow using that hash. So a modernized interface also. I would like a modernized interface to show me what extensions manager would show me, which it kind of does, but not exactly how I wanted it. So the extensions manager, or extensions pane returned pane. If there's anyone from Apple's style guide team in the room, sorry if I used or didn't use an L in that location. Feel free to flame me later. But here we can enable or disable various functionality, like here's the Dropbox option for Finder extensions, which is this nice little drop-down menu item. Some extensions are apples also, and we don't want to block these. I've done that, and the results are disastrous. So you never know where things are being used. For example, the credential provider, like all kinds of apps use that for their keys. So if you crash iCloud Keychain and the ability for Keychain itself to be invoked and substantiate objects, then all of a sudden there are tons of things in the operating system that just don't work. So that's why it's bad to have extension conflicts, I guess. So who thinks all of this looks simple so far? It's not hard. Just throwing that out there. We'll get into summarizing and making simple command line versions in a minute. But as a developer, it can be really hard to know which extension I want to use, and sometimes I leave cruft in my code where I tried to do it one way and then it was another way, and then I've got like things in places I didn't really want things to go. So the other thing I can say is when we're registering for some of these extensions, some of them can be called without a lot of fanfare. Others, you need like an actual Apple badged employee to hit a button to give you access to that extension or an entitlement to the extension. You can always load the extension, but if you don't have an entitlement, it's not going to work. So when you go to get that entitlement, you register an app ID, and here's all those extensions. And if you notice, there's all these pages, and we'll just wait for this to cycle through. I thought about speeding it up, but it looked weird, and I didn't want to give anyone like motion sickness right after lunch. And I definitely didn't want to give the whole room motion sickness right after lunch, because there was this Simpsons episode where that happened, and it wasn't good. But another aspect of this, digging just a teeny bit deeper, is a lot of these extensions have little configure buttons beside them, if you'll notice. And each one of those configure buttons, it took me probably a day or a day and a half to figure out how to consume that. And this is a link to one just for the notifications. But it's worth mentioning that, like, importing the template and getting that up and running, especially if apps are communicating with network services, then it becomes a potentially much more fraught with peril implementation, especially when we get into things that are cryptographically signed, like passkeys, Kerberos, anything with assertions, IDPs. So the installation process, I said we get to what that activation process looks like earlier. So the extension is installed in Contents Library System Extensions folder within an app, and this is System Extensions. The app is installed in the appropriate applications directory of the system, which is supposed to be apps and applications utilities, but I've also seen them in application support. The code, which I got a signature when I did the web interface on the developer site a couple screens ago, is then added to the extension. If anyone's tried to compile their own version of Nomad, you have to replace Joel's bundle ID with your own and add the signature. I did an article just on that because I figured people would want to, and no one that I talked to actually knew how to do it. And this is one of those places where when you're preparing software for distribution, you can add this or not, and you have to actually change things in the code, which can potentially break things. Anyways, the entitlements in the code signature has to match the entitlements from the developer portal. The identifier in the activation, I like this word. I think I will ponder it for a moment. Moving on. The identifier in your activation request matches the one in the system extension bundle, and the ID isn't already in use by another system extension. I did this once also. This is easy to do when you're in development, because when you're in Xcode, you're building and running, and then you go to install it from the App Store, and you've got conflicts that you've created. So you have to clean up your build directories. So extensions can have an entitlement. One other complicating factor, You see this mostly in SDKs, if you're bringing in an actual SDK like Auth0 as an example. So extensions can have an entitlement that allows them to be redistributed within someone else's software. So as an example, if you go to your MDM and you go to add a team ID and a bundle ID, and then you have to add one from a whole other company who you've never heard of, this is why that can happen. Because hopefully, if developers have done their job right and we're importing SDKs, the end consumer doesn't know anything about whose SDK we're implementing. Having said that, admins need a deeper level of understanding about the software we're deploying. So it's fair to have that happen. And I would say the other thing that makes all this stuff easy, I said it looks simple, and then it seemed harder, but like the Apple developers who write the stuff, they monitor the developer forums. So as an example, huge call out to Quinn the Eskimo. Anyone who's posted something to Apple developer forums probably has a very high likelihood chance that Quinn has responded to their request and helped them. I was going to put a picture of Quinn Medicine Woman because I always assumed Quinn was a guy because to me, I had a D&D character once named Quinn and it's always seemed like a masculine name to me. But then I remembered Quinn the Eskimo, or Quinn the Medicine Woman. And then I remembered, oh, I have to get, like, I can't put other people's copywritten content. Anyways, it just seemed like too much work to try to get a release on a screenshot or an image off Google Images. So again, just to kind of jump into what's different and repeat a couple things and then build on a couple things. The new version of extensions don't access the kernel directly. This was a huge problem in the OS 8.9 era. They would literally interrupt the kernel when it was processing information. Kernel extensions could do so as well. So like, I remember one time I had an antivirus tool that had a kernel extension. There was a virus. It was massive. I don't know why anyone would build a virus this big. It seems very suspicious just to have a file this big. But it got blocked and it buffer overflowed the system and the kernel just stopped. It was one of the last times I had an actual kernel panic. So they load or register when an app that has the extension is open. This is one of the issues with system extensions on iOS, because when you close an app in iOS, everything that is attached to the app bundle itself is then unloaded. They register on unregister on first reboot when we delete them. And then to dig a little deeper, registration is handled by the plugin kit daemon, which is just PKD. It also performs house cleaning if like you move something or unload it or interact with it through system extension CTL. So then we get into telemetry. I'm going to grab something to drink because I've been going for half an hour without. It's a lot of words. Am I going too fast? All right. Can I go faster? Yeah, I'm not Duncan McCracken. Okay, so an example command. So I mentioned PKD. So here we're querying plugin kit to show me all applications. There's a lot more than just this. This is one extension from one app that showed up when I did this. MindNode, you can judge me for mind mapping. It's fine. I know it's douchey. So the SDK that we're using, aka category, is com.apple.quicklook.thumbnail, and the location of the app itself is applications mindnode.app. So plugin kit, I always throw extraneous V's at the end when I use it because I like verbose output, and I'm grepping out applications. If you notice, one of these is widgets. And these are those sweet little things. This is going to be a way bigger thing in the next couple years, because you know how in the next OS we can take our phone and put it over here on our bookshelf or nightstand when we're going to bed, and it can show us all these cute little widget things. I have a feeling like some, like Traeger grills, if anyone's got one of those, they have a great widget. It shows me the temperature of of the the stuff that's grilling and the temperature of the grill, and it's a great, it's probably one of the best widgets I've seen. But you know, widgets are just extensions, and it's a Swift UI view, and you can build a widget in 15 minutes if you're good with Swift UI. And Swift UI, in my mind, is way easier than trying to triangulate weird CSS issues in HTML. So yeah, those widgets, you know, I can query using Plugin Kit, and I should have zoomed in on this and shown you a bigger one, but whatever. I can query Plugin Kit to show me every widget on a machine very easily. So here I'm listing all Safari extensions. One thing that's extra dangerous in my mind about Safari extensions is they can load in WebKit. So the number of app vendors that use WebKit to substantiate a web view in an app is fairly high. So if I then, as a bad actor, let's say, can pipeline some of that information back to a web service, that can be icky and not great. So here I'm listing active password managers. This is going to be extra important in a passkey world, because the same entitlement gives access to passkeys that autofill gets. So as an example, if you're using 1Password or Secret Chest, you can't be using Secret Chest, but someday you may be able to. But if you're using one of those to store your credentials, one of the tenets of the backend protocols underlying passkeys, WebAuthn, has always been that you need someone present to allow a passkey to be used. Well, as a credential manager, I can choose not to make you be present in order for a passkey to be used. So suddenly we're able to create and replay or man-in-the-middle passkeys. So, you know, if I'm an admin and I have certain security requirements, I want to know all of these things. But these are a lot of variants of the plugin kit command, or the sysext commands, or, and if you notice here under credential provider, defaults read, wait, this is actually in a property list in preferences too. So that, in this case, it is in a common location. However, 3 of these no longer exist because they're previous developer builds. So I show 4, only 1 lives. And then there's also share sheet extensions. So, you know, that would be, oh, I want to enable this in Dropbox, or, you know, when you go to share stuff. So. And then there's the SSO extension. And the reason I included this screen is I wanted to highlight the fact that even if I'm trying to understand better what Apple's doing with one of their things, I can actually use their usage of extensions, because they build everything because they need it to some degree, or at least their developers need it. And developers ask for them to add things, but the reason they build the original thing is because they needed it to give some other functionality, typically. So to dig into this just a teeny bit, what I'm saying, as an example. So here we see the first entry is Okta using the IDP extension that Apple has, the Apple SSO IDP-extension. And then below that, we see Kerberos is using the same extension. And that's native. That's an actual system library, private frameworks code that's being used. So it's not always just me trying to figure out what other people are doing. Sometimes it's also me trying to figure out what Apple's doing on my machine. Because I might say, oh, I want to build something else on top of that. Or because I might want to say, oh, that user opened that thing, and now I know that that thing's calling this other thing. So it's also worth mentioning that in the classic OS 9, OS 8, OS 7, OS 6, et cetera era, counting down till they were introduced, that extensions could be control panels as well. And that functionality was recently reintroduced So if you notice, com.apple.software update settings dot extension, or com.apple.profiles dash settings dot extension. So we're extending panels to contain additional information. And we can open those directly, which is super cool because like in self-service, I can build a workflow or just a link that opens one of these directly and say, oh, go to your printers, you know. Very nice. Some of these also provide a whole lot of telemetry. So this is ESLogger. I'm just calling it. The reason I included this screen in here, or this paste in here, because that's not a screenshot, is because in this case, I'm calling the endpoint security framework from Bash. Like I'm not actually writing a Swift app and bringing stuff in. I'm actually just calling ESLogger and grepping out what I want to see. It's a fire hose of information, and it's very intensive on system resources. And the only person that should probably be talking about this in the room is Dan, so feel free to ask Dan if you want to know more about that. Because he has spent a lot of time reducing the amount of information that's pipelining, which I think is very prescient, I think, would be the word I would want to use if I go back in time 3 years when you first showed me. So there's plenty of these pre-built extensions. There's plenty of pre-built entitlements for these things. Some things aren't extensions, but they're libraries. Some things aren't libraries, but they're frameworks. And that just comes down to how many rules they want to put around how we consume some of these objects that they give us. So file providers, news, widgets, etc. Another thing that I would like to throw in here is I don't feel like I feel like I should have put this way earlier in the session. So these extensions are bundles that live inside our application bundle, right? And in Xcode, we call those targets, which was why in that very first screen, I said file new target. Every object, application bundle, application within an application, system extension or network extension within an application, those are each just another target that our app is building. Each target can have its own permissions, its own users that they sign in as, its own functionality. And furthermore, we have to entitle every target to be able to communicate with each other target in Xcode when we're building these. So that's why in that Nomad example that I used, Joel's bundle identifier is pasted because for each target, it has to match, but not be, and yet be uniquely named. It just has to be prefixed with the same. So we can also have minimum OS installment requirements for each target. So as an example, I could have, oh, this is the old way, this is the new way, and my installer will handle what goes where. So in my code, I define a class, and then I call the extension in a function once I've added that target, and it's that simple. Like on top of that, then I have to build a bunch of Swift UI views, or I have to interface with the data in ways that Apple wants me to. As opposed to the browser extension example, and for people who do most of the work in browsers, these are now kind of the new frontier, where it's just a JavaScript. So again, here I've got, this one I wrote, and I'm going to blame Prince Harry, because I got tired of seeing the term Prince Harry on all my news feeds, and I decided to see something different. And I'm not going to tell you what it was, but this extension was meant to showcase functionality more than anything, but I just search for a term and replace it as it's rendered by a web page in Safari. Now, I could just as easily have sent that information to my own web server, basic REST endpoint. In fact, I could hide the data in protobufs and pipeline it back. So every time you type in a username and a password, I'm just popping that back to myself. I would never do that, but I would like it a lot if you would install this extension. And then example 3 is that ES logger. And the reason I include this here is I wanted to remind myself to talk about symbols and NM. So when I call one of these Apple frameworks and it compiles, then what I called it as is kind of obfuscated. But it leaves behind a symbol, which is what the Swift interpreter uses to provide that functionality. Apple gave us a command called nm. I'm not sure if anyone's used this, but nm allows me to say, list all the symbols for an app. And then I can grep that. So in the endpoint, in the ES logger, as an example, I can grep _ES_ because all the symbols for the endpoint security framework have _ES_ in them because that's the naming convention that they use. If I wanted to do something similar for the autofill or password or any of the credential stuff, it's usually AS authorization, stuff like that. So normally you can look under the hood, and even if you can't see in a plist or somewhere else what's happening, you can kind of semi-figure it out. And I'll get back to why that's important in a minute. But NM, if you read the man page for NM, it takes a second to run because it has to analyze all the symbols. But it's a nice little tool when you're looking for stuff. Spelunking, so to speak. 24 minutes. Crash reports in console, I don't have to dig into this too much, but the com.apple.extension kit service, if you write as crappy of code as I write, by the way, I have a team of developers, and they do more of the work, so don't be afraid to use any of the tools out there that I may happen to work on. But in here, I can kind of try to dig into why something's leaking information, because not all crash reports are actually crashes. So other types of extensions, I mentioned the browser extensions and the danger that I see in them. And I would say for anyone who's got like OS query environments, there are OS query options for surfacing this kind of information. It's also, I'll have a couple bash commands in here, and I even wrapped one of them up into an extension attribute if you're using a Jamf environment that will just show you these things. So if you have oh, this is a bad extension, I would personally rather white label extensions or allow extensions than block them by default, but that's aside from the point. Good old battle days of browser wars, 1999, Microsoft ladened us with this horrible thing called browser extensions with Internet Explorer. The artist formerly known as Internet Explorer wouldn't be Edge because that's really just another browser under a different name. But they initially began with plugins, which were compiled binary. So they had the same level of permission, but you didn't have any telemetry into what they do. And this is why the ECMA, or whoever that is, that governs JavaScript, lobbied to have the W3C standardize browser extensions as JavaScripts. Most sync between computers, what I mean here is they're not totally reusable, but in general, the browser extension that I write for Firefox can mostly be used in Chrome as well, or Edge, or vice versa. So I include another link of a tool that I did. This is when I was first starting to do passkey research. I made a little passkey inspector, so you load this into your browser, and it will show you the raw content of every passkey as it's being passed to and from your device. That required, I'll get into that later. I'll just skip that thought for now. It's funny when you're writing decks and you're trying to kind of pedagogically align what you're going to talk about and not get to one thing in front of another, but I've never been good at this. So So Chrome extensions are the next one. Introduced in 2010, you see this find command. This is incredibly annoying because it takes so long to run, and if you're trying to render information into a window quickly, but here I'm just looking in library or tilde library application support Google Chrome default extensions for everything with recursively for everything with manifest.json. You could get a lot more granular and like do some text globbing to get right at what you're after if you would rather. And then I did publish a list of APIs that Chrome makes available. These are things like allow a user to see, or allow an extension to see the contents of a web page, allow an extension to see all JavaScripts on a web page, or there's a whole bunch of, it's basically permission sets in a way. And then there's Firefox extensions. So the only thing to know here is the last bullet, show me a list of all of them. And I don't think I uniqued it, but because you can have 2 or 3 of the same one. So Microsoft Edge extensions, if you look, last bullet, same thing. Again, this presentation is up on my site, so feel free to go and copy it out of the PDF there. But this is just super quick, dirty, 3 commands to see all the browser extensions that aren't Safari that are running on the machine. So I mentioned that they're similar. They began to conform to the Chrome APIs in 2020 for the Mac, and were introduced in iOS for 2021, or Safari extensions. So Safari was the last holdout where they did extensions differently. They weren't just JavaScripts. Safari is also one of the only ones that forces all the extensions to be unaltered from their installation state. But again, extension-based malware is more portable because now we have the Irish potato famine situation where everything is the same. I can write once, run many, basically. Oh, the last thing, I mentioned hiding things in protobufs, but I can intercept data and then I can hide it in blobs of other data and pipeline it to other places, which I consider to be the biggest risk of all browser extensions. So this is what it looks like on a screen. I'm sure everybody's seen this, so I don't have to dig into that. So my passkeys research, navigator.credentials.get is a function or an endpoint that every passkey-enabled website will have, or the browser has, to interact with that. I can override that function, and I can take over as the passkey manager. That's not the right way to do it. Apple released good APIs. They're all in beta for the next operating system. But the fact that that JavaScript allows for function overriding, and the fact that I can intercept any JavaScript that's running and take its place, or any function within a JavaScript that's running and take its place, gives me a whole lot of options. So if I'm beating a dead horse, browser extensions are very, very dangerous, and we should all be limiting what browser extensions are allowed to be run. So the other thing, Apple introduced beta options for API endpoints for passkeys, but we kind of knew it was coming because they put this random weird interface into the privacy and security options, before they introduced it. So that was kind of cool. Who's still awake? All right. So so here I am doing all this extensions work for most of COVID, and then one day someone in the Jamf Slack, in the Mac admin Slack, and you all probably should have been in the Mac admin session at this time, by the way, just throwing that out there. But then someone says, why hasn't Jamf added a system extension section for computer inventory in Jamf Pro? And I'm like, well, because it's really hard. there's a whole lot of stuff. And what exactly do you want out of all the stuff that there is? But then when I thought about it, I'm like, well, give me 5 commands and I can get almost everything native. So this doesn't include Chrome and Edge and Firefox and all these other things. But 4 commands, and here you go. I've got all the extensions. So I had originally thought 5 commands, but then I decided I didn't care about the output of the 5th. So I made it a script, posted it to my GitHub. I copied that and made it into an extension attribute. So feel free to go get that. But then I decided to go a little further because that's really only showing me what's loaded. So what if someone installs something that hasn't opened it yet? Is it still dangerous? Do I still care? So I went a little further and I said, hey, show me all the .appx bundles. Show me all of the entries with a system extension in it. And if you see extensions man, so I made this all in Swift, compiled it, and in the very last slide, there will be a URL to it, but the GUI I showed originally, I started with a command line interface. And so that's still available. And you can run it and see a list of everything and pipe it into an extension attribute, and it's open source, and it's also a fully permissive license, which I did hoping that maybe some of the device management vendors might steal my code. By steal, I mean I gave it to them, so hopefully they will take it and make it better and put it in their product so that I don't have to keep maintaining stuff that I don't want to maintain, because I'm quite lazy. But then I decided to take Extensions Man further than just show me all the .appx bundles. And that's when I added -n for network extensions, -s for system extensions, and -all for all extensions. And later I added Firefox, Edge, and I should be getting royalties for the Edge browser, right? It's my last name. Thank you. I feel heard. Mostly because I'm in front of everybody and you have to hear me. And then I added a -raw option because some are prefixed coming out of other command line tools with state that I didn't like. So if you're going to build any workflows on top of that tool, feel free. It's available as uncompiled and compiled code, so you can compile your own, sign it, do whatever. So then I had the idea for the GUI. Does anyone know what this is done in? Close. Oh, no, this is actually just Apple's spreadsheet tool, Numbers. I love to mock software in Numbers because nearly everything I build is table-oriented. Like, I'm not writing games. I'm not creative. So nearly everything I do is just, I'll start with Numbers, and then I'll try to lay it out how I want it in Numbers, and then I'll try to build a UI that looks kind of like that. Or if I got something for free, or I'll try to make it look even better. But I ran into one more problem, and I said I'd come back to this. When I was talking about the endpoint security framework, I realized, because there was a piece of software on my machine that did this, I was like, wait, where are their extensions? Like, why is this software that I just installed just doing something that should require an extension to give me the information about my machine that I want, but it doesn't have an extension? So if you notice here, I wrote another tool, and this is also linked. So nm will look for all of the symbols in a single binary. So I made another one, a little shell script called mn, just reversing nm, that would recursively look at the whole operating system if I told it to, or within a recursive app bundle, for the symbol that I wanted to find. So in this case, if I use that, which is just recursively doing nm, then I see, even though Malwarebytes wasn't loading an extension, they're still calling the endpoint security framework, which I mentioned earlier you can just do from a command line. So they figured out a way to load objects that I didn't know was possible until I found them, and then they were kind enough to explain it to me. They've got employees on Slack. It's wonderful when vendors have employees on Slack. So yeah, I decided to look for other vendors who might be doing the exact same thing, and there were none. So that made me very happy, because the idea that someone else might have figured this out kind of bummed me out. So anyways, there's the URL for Extensions Manager. This whole presentation was basically me going through my process to Splunk so that I could build Extensions Manager. I did want to have a version up for the App Store. However, there are so many things that require admin privileges in there that it has taken me longer to parse through all the app bundles in native Swift without using any Apple tools to get there. And there are weird things like Firefox having multiple profiles that are harder to kind of get through. So I added browser extensions for these sessions when I started getting into that a lot deeper. And that brings us, with 10 minutes to go, to the future of extensions. So I guess I'll give you the option. I can either bang through these slides, or I can save this for a future presentation and move to Q&A. I guess first, do we have any questions? Did I go too fast for questions? I know I wasn't that complete. Okay, the future. So I think Joel and I, through all of this, have been talking quite a bit. I think he put into perfect words what I think of as the future of extensions. And he said, AppX used to be pretty benign, but they aren't really anymore. And to unpack that, you know, the things that I would have thought that would be system extensions that are app extensions, it's not consistent. And there's not consistent documentation, there's not consistent ways to implement these, and there's just incompleteness in different places. So, but we do expect to see more of all of that, and also more options for telemetry into what these things are doing and privacy. And when I say telemetry, I mean granular control. So as an example, autofill extension enable, now you've got passkey autofill capabilities, but it would be great to say these are the things that those can be used in, or if I'm doing a network extension, to say, oh, I actually only want this to be able to do proxies, or I only want this to be able to report on information and things like that in the GUI. There is a design pattern for this. So when I think of vendors who do this well, I like the way Chrome lays it out. Like, okay, here are all the API endpoints for a Chrome extension, and then now we're going to show you what level of permission is available for every API endpoint. That would be terribly cumbersome if we did it system-wide, but some of these extensions, any system extension, any endpoint security, any network extension, I would see as being deserving of that kind of thing. The other thing, I mentioned OTool. I can, query dependencies using OTool. I did write a reverse of OTool I called Ludo, which recursively looks for dependencies for something that I installed. But I don't think it's possible yet to just outright block dilibs. Dilibs are potentially alterable pieces of code that we bring into our software. But what would be cool is, so here's Xcode, and there's an option for each target for a hardened runtime. And each one of these checkboxes I would love to see as an option of something that I could block org-wide in MDM. I think it would be a very small lift to build that into the MDM framework, or build a profile that enables it. But I would love to be able to say, in my organization, we don't allow any software that has dilibs. in my organization, we don't allow any software that isn't a hardened runtime. We don't allow any just-in-time compiled code. You know, to me, that is, it, it, it's, it's just a higher level of protection that I can ensure org-wide, if that makes sense. So I'd love to see that. And that would, I think, require device supervision and MDM. So a lot of this stuff, I would love to be able to do more, I think. And having worked on MDMs, I can think of very easy ways for these to fit into the MDM protocol. I'd also like to see one-click multiple entitlements. I think Firefox does this really well. Chrome does this really well. When I load a piece of software and it wants access to my camera roll, to the, you know, I get that click fatigue. And so that last click to allow, I'm probably not reading it. And I've spoken to Black Hat. Like, you know, so if I'm not, I don't think anybody is. There's also lots of cruft all over the operating system looking at the old extensions. I should have zoomed in on this screenshot as well, but like, if you go to system information, there's just lots of old stuff sitting around that hasn't been cleaned up yet. So I think in the future we'll see that stuff start getting cleaned up, especially when Apple chooses to modernize those apps that show that with SwiftUI, because in a lot of cases that hasn't happened yet. Also, new third-party options. My hope again is by building this extensions manager thing that I would get a cease and desist. That hasn't happened. So the next best thing would be if device management vendors just took my code or made it better, because they probably have real coders on staff, not some hack like me. And I didn't have to build it anymore because it was just part of some other tool I consumed. I have no idea what I was talking about here. I like to hack things. And the whole privacy and protections thing is super annoying when you're trying to hack things. No offense to your privacy or your protection. Just kidding. Oh, the other thing that I did add is sometimes when you're just installing things and testing things and you leave things, you gave permission to something, but it sure would be great to be reminded later, or have a little like permissions privacy wizard thing to say, oh, you know, remind me about all these things. So annually, let me entitle things or something like that. There tends to be an accidental version of this, which is anytime they change their code enough, they have to ask you again. So it's there, but you know. Anyways, I'll wrap it with there's Extensions Manager, use it, hate it, or rebuild it. Thanks. And since I have 3 minutes, I don't have to use it, but thank you so much to the Penn State people and the volunteers. I am so happy to be back out in the real world.